I've never felt so small staring at something so vast, and yet so aware. It started one quiet night when I noticed a faint, trembling blur at the edge of my telescope's field. 3i Atlas. Just a dot of light against the black, but something about it felt deliberate. The glow was cold, almost bluish, and not just reflecting the sun, it seemed to come from inside. Pulses, subtle but persistent, flickered across its tiny nucleus in patterns that I couldn't immediately explain. Why those intervals? Was it the comet shedding gas in bursts, or something else entirely? I don't know. Some colleagues suggest interstellar comets naturally carry unusual chemistry that can cause strange photometric patterns. Others are quieter, just as puzzled. I tried to run the standard analysis. The orbit calculations didn't match anything typical. 3i Atlas wasn't looping neatly around the sun, it was passing through, like a visitor cutting across a quiet town without looking back. I noted it officially as early activity at an unusual distance. Unofficially, I couldn't stop thinking, why now? Why like this? Then came the anomalies. One night, the coma brightened suddenly, not gradually as expected, but in a sharp jump. I checked the instruments, recalibrated everything, ran multiple scans. Same result. Some researchers argue that interstellar objects often produce odd, early emissions. But the pattern here, these mini-spikes in brightness, almost rhythmic, felt too structured. And the color? A soft bluish-green in multiple filters, faint but noticeable. It shouldn't have been dominant at this distance. Some whispered it meant exotic gases, or cosmic ray aging effects from billions of years traveling between stars. Others hinted, half joking, that maybe the comet wasn't entirely natural. I didn't say it aloud. But the data itself began to hint at something I couldn't name. Bits of radar data vanished. Access to raw logs was suddenly restricted. Maintenance, they said. Officially, nothing unusual. But I kept a mental note of the anomalies, timestamps that skipped, files that disappeared, instruments that recorded shifts without explanation. The timing sometimes seemed deliberate. A friend at another observatory texted me, "Did you notice your timestamps jump?" I checked. Yes. Frames from the previous night didn't exist, or at least, they had no recorded time. I went outside and stared up at the sky, trying to tell myself it was just the early morning chill, the faint glow of the comet reflecting off the atmosphere. But something about 3i Atlas didn't feel passive. A soft hum of thoughtlessness? Or awareness? Later, the brightness monitor registered another spike, different this time. Not a steep rise, first a dip, then a surge, capped at the top as if some unseen force held it in check. Micropulses rode along the main peak, too fast to be thermal, too clean to be dust. I saved the file, staring at it long after the data refreshed. My stomach twisted. Around noon, a colleague from image processing dropped by. Normally upbeat, today she looked pale. "Have you seen the latest composite?" she asked. I shook my head. She connected a drive and displayed a stacked image from multiple telescopes. The comet appeared as a grainy smear, but faintly, almost invisibly, a thin ring had formed around it. Not a tail. Not a halo. Something else. A broken, jagged ring, as if tugged or stretched. Contrast adjustments revealed fractures, irregular segments, like cracked glass surrounding a pebble. I leaned closer. Goosebumps ran up my arms. "What is that?" I whispered. "No idea," she said, but her tone lacked conviction. "Probably an artifact." Artifacts don't move. Artifacts don't stay consistent across instruments. Artifacts don't mimic geometric patterns. Before I could ask more, her phone buzzed. She frowned, unplugged the drive, and left quickly. Door slammed behind her. I checked the composite again, wiped. Not moved, not archived. Gone. Later, a message popped up on our secure chat, "Stay off the raw feeds today." Maintenance. Maintenance? On the raw feeds? That never happens mid-cycle. I typed back a question. Bounced. User offline. By afternoon, the building felt heavier. People moved with a little more urgency, conversations hushed. Doors closed faster. Monitors drew nervous glances, as if expecting something impossible. At 4 p.m., an unplanned calibration meeting was called. Calibration is routine, usually a 5-minute task. But everyone showed up. The head administrator spoke vaguely, temporary inconsistencies, upcoming data restrictions, outside collaboration protocols. Vague, scripted, uneasy. He avoided eye contact. Back at my station, I found my access altered again. Raw spectrometry logs now required a new layer of authorization. The request form? A blank grey icon. I hovered my hands over the keyboard, unsure what to do next. Then the floor vibrated. Longer this time. Low, slow tremors, like the building itself was breathing. Seismometer? Flat line. The air warmed by a degree or two. Subtle, localized, almost like the metal frame of the telescope had its own pulse. I placed my hand on it. Vibrations. Light, rhythmic, almost alive. Machines hum. Machines rattle. Machines whir. They do not pulse. My heart hammered. I stepped back. The vibration faded. The temperature normalized. And somewhere out there, 3I Atlas kept drifting through space. I couldn't sleep that night, not really. My mind kept tracing the comet's path, chasing its faint pulses across the void. Every time I closed my eyes, I imagined the jagged ring, those fractured segments, as if some invisible hand had rearranged them while we weren't looking. Morning brought no relief. I arrived at the observatory before anyone else. The control room smelled faintly of coffee and electronics, a comforting mix, but the screens felt different. Watching the telemetry feed, I noticed the brightness of 3I Atlas was subtly uneven, slightly stronger on one side. Not by much, maybe only a few percent, but enough to be consistent over multiple scans. Some colleagues whispered that asymmetries like this could be caused by outgassing or rotational tilts. Others suggested dust jets could temporarily alter the light. But even the most conventional explanations didn't fully fit the way the variation repeated almost rhythmically, like a heartbeat. By mid-morning, another anomaly emerged. Certain radar returns that had been steady for weeks suddenly vanished. No error messages, no logs, just missing frames. Why? I don't know. Some researchers suggested network glitches or automated filtering. In the network, people speculated about interference from high-altitude satellites, cosmic storms, or, whispered cautiously, something deliberately masking the signals. The more I observed, the stranger the comet behaved. Its tail seemed to sway independently of the solar wind, subtle shifts that repeated over consecutive nights. At first, I thought it was my imagination, a trick of perspective. But then I compared frames from other telescopes, same pattern. A message arrived from a colleague at a radio detection array, signals from your sector fluctuated again last night. Narrowband, not repeating. Not repeating. But precise. Intentional. I didn't answer immediately. Instead, I checked the comet's photometric curves. The micropulses were still there, the slight stair-step pattern continuing. The peaks aligned almost too neatly with the changes in brightness I had recorded last week. Random natural processes don't usually produce such alignment. Some researchers, in private chats, suggested resonance effects or environmentally induced emissions. Others hinted at something more, so directed, though no one wanted to put it in writing. Around noon, I went outside for a brief walk. The observatory sits atop a ridge where the wind is sharp and dry. Usually, it clears my head. That day, it felt different. Electric, almost. I paused and thought I heard a faint static hum, like distant machinery or a radio signal I couldn't pinpoint. Probably nothing. But my instincts told me otherwise. Back inside, the image processing team had compiled another stacked frame. The ring around the comet was clearer. Jagged, fractured, but now there were hints of smaller structures inside the ring. Tiny, faint clumps, almost imperceptible. Some researchers believe interstellar comets can carry frozen clumps that reflect light irregularly. Others suggested micrometeorite impacts. Yet the arrangement of the clumps seemed patterned, subtle but repeated in each frame. I froze for a moment, realizing that the comet was behaving in ways we didn't expect. Why now? Why at this distance? During lunch, a colleague mentioned something odd. Satellites over the region reported temporary magnetic anomalies around the expected trajectory. I asked for details. She shrugged. They didn't specify, just anomalies. Some fields fluctuated, then returned to normal. I made a note in my private log, temporary electromagnetic fluctuations. Some observers online speculated about interactions between the comet's outgassing and solar wind. Others whispered about artificial fields, directed or controlled. That evening, I ran orbital models again. Minor deviations cropped up. Tiny, subtle changes that seemed statistically insignificant, yet repeated nightly. Non-gravitational accelerations. Unexplained, inconsistent. Sometimes it accelerated faster than solar radiation pressure could account for. Sometimes slower. Some researchers whispered that jets could do this, yet no configuration of jets could reproduce the precision I was seeing. A text came in from the radio array friend. We measured another fluctuation. Narrower bandwidth this time. Seems directional. Directional. I stared at the screen, heart pounding. Comets don't direct themselves. Not like this. Later that night, the observatory's systems behaved strangely. Minor instruments rebooted without warning. No error logs. No alerts. Just silent resets. By now, I was keeping a separate, offline copy of every raw frame, every telemetry snippet. At 2 a.m., I noticed a peculiar pattern. The twin peaks in the spectrometry data, the ones that had been subtle at first, were now appearing consistently, almost like punctuation marks. Every pulse in brightness seemed to coincide with these peaks. Coincidence? Some would argue yes. Others, like me, began to wonder. Around 3 a.m., I glanced out the dome slit. The comet was invisible to the naked eye, too faint, yet I imagined it drifting silently, older than our planet, carrying questions we weren't ready to answer. I wondered if it could see us as we tracked it. Crazy, perhaps, but the thought didn't leave me. By morning, another anomaly appeared. Radar echoes from the comet's periphery had shifted slightly. Slight, almost negligible, or barely measurable, but repeated in 3 consecutive scans. I cross-checked the instruments. Calibrations were normal. Nothing in our control systems could have caused it. Some researchers speculated that interstellar comets sometimes carry volatile cores that can shift unpredictably. Others whispered about internal fragmentation, shielded volatile pockets reacting to solar radiation. And then, quietly, someone typed in a private chat, or maybe it's adjusting itself. Adjusting. Not a term we use for comets. Not in official reports. But it lingered in the back of my mind. By afternoon, the observatory felt heavier. People moved like they were aware of something we couldn't explain. Conversations became cautious. Monitors drew nervous glances. And 3i Atlas drifted through the void, silent, unknowable, and perhaps, just perhaps, aware. I knew I was watching more than a comet. I wasn't sure who, or what, was watching back. I remember staring at the monitor that night, a creeping tension in my chest, like the comet was whispering secrets I wasn't supposed to hear. The brightness spikes had started to show subtle modulations again. Not random, not smooth, tiny stair-step jumps, almost imperceptible, yet repeating. My instinct told me it was more than thermal or dust behavior. Some researchers suggested it might be a rare interaction between solar radiation and volatile ices, forming microjets that flicker unpredictably. I can't argue with the physics, but even they admit the timing is unusual. Almost coordinated. Around midnight, I noticed another anomaly in the radar returns. Certain echoes, previously stable, now formed faint arcs around the comet's nucleus. Thin, ephemeral lines that weren't tails, not exactly. Some colleagues whisper that these could be debris or tiny fragments being ejected, but the arc symmetry didn't match any known fragmentation pattern. Another possibility they floated, electromagnetic interactions with the interstellar medium. Yet the arcs remained consistent for hours, in ways that should have been impossible. By 1 a.m., my phone buzzed. It was a brief message from the radio array contact, a directional fluctuation again. We think it's repeating, intervals slightly faster. I froze. Repeating. Coordinated. Comets don't repeat signals, at least not intentionally. I stared at the screen, blinking slowly, trying to convince myself this was just chance, a misalignment of datasets, an optical illusion. Some part of me, though, refused to accept coincidence anymore. The observatory felt unusually quiet. Even the ventilation seemed to whisper instead of hum. I leaned back in my chair, watching the data scroll. Small peaks aligned with larger pulses, forming almost a rhythm. Subtle, almost musical, if you imagined it. I thought of theories floating online, resonance, self-oscillation, or, more daringly, something actively responding to its environment. Around 3 a.m., another anomaly appeared. Thermal readings from the comet's core fluctuated independently of solar exposure. Not dramatic, barely detectable, but consistent with the repeated stair-step brightness. One of the interns mentioned it casually, like it was nothing. I don't know if anyone noticed, but the thermal core readings dipped, then rose in sync with the tail movement. I noted it in my private log, coordinated core behavior. Some analysts suggested a natural explanation, internal rotation of unevenly heated ices. Others whispered in private chats, could it be shielding? Or something inside controlling the outgassing? By 4 a.m., I couldn't resist walking outside. The cold air hit my face, and the sky was a deep, endless black. 3-hour Atlas was invisible to the naked eye, yet somehow present. I tried to imagine its trajectory, thinking of the fractured ring I'd seen in the composite images. Why now? Why at this distance? What was triggering the modulation? Around dawn, I noticed more irregularities. Access logs for certain datasets had been altered. Some files, previously unrestricted, were now partially blocked. No explanation. No announcement. Only subtle gaps in the timeline. I whispered to myself, why now? In the same hour, one of my colleagues brought a set of spectra from a nearby observatory. Tiny peaks in the emission lines, previously overlooked, were now visible. A faint structure inside the dust cloud. Some researchers speculated about chemical layering, others whispered about hidden cores or material shielded from solar radiation. I couldn't stop staring at the images. The tiny structures seemed deliberate, not chaotic. Not natural. But I didn't write that anywhere official. I only logged it privately, something in the nucleus resists exposure. By late morning, the comet's tail showed subtle curvatures, inconsistent with solar wind direction. Some researchers offered mundane explanations, uneven mass loss, rotational tilt, dust grain orientation. Others whispered about electromagnetic fields. I kept both possibilities open. Truthfully, I didn't know which was closer to reality. In private, someone mentioned an odd observation from a satellite, a faint electromagnetic pulse aligned with the comet's trajectory. No source identified. No report published. Probably natural, they said, but I doubted it. By afternoon, another strange pattern emerged. Brightness pulses repeated at intervals, slightly varying, almost like a signal trying to adapt. I ran simulations. Nothing in conventional comet physics produces these intervals consistently. Some colleagues online speculated about interference, instrument quirks, even cosmic music, though quietly, in corners of forums. At sunset, I stepped outside again. The horizon glowed orange and purple. 3I Atlas was a pinprick in the sky, older than anything humanity had ever touched. The more I watched, the more it felt like it was aware of being observed. Not sentient, at least, not in any way we could recognize, but responsive, subtle, deliberate. By nightfall, the anomalies escalated. Radar echoes, spectral peaks, brightness spikes, all aligned in ways that made my training scream impossible. I logged everything in a secure offline folder, copied every frame, every reading, hiding it under generic file names. Some colleagues noticed my behavior. Some whispered, "Are you seeing what I'm seeing?" Yes. I was. And that's when I realized the comet isn't just passing through. It's interacting with the environment, reacting, subtly, almost invisibly, but undeniably. Every dataset reinforced it. Every anomaly hinted at intention. Some theories online suggested natural resonance, cosmic oscillation, or volatile-driven dynamics. Some researchers believed in shielding effects, internal fragmentation, or chemical stratification. And some, quietly, dared to wonder, is it something more deliberate? I didn't have an answer. But I knew I was standing at the edge of understanding something far beyond conventional astronomy. And no matter how much I tried to explain it rationally, a small, stubborn part of me kept thinking, whatever 3I Atlas is, it isn't finished showing us its secrets. I don't think I've ever felt this small under the night sky. 3I Atlas was out there, somewhere beyond our reach, carrying mysteries I couldn't touch or explain. Every monitor in the observatory seemed alive, flickering faintly in sync with its presence. My own pulse matched the rhythm of the data. Earlier that evening, I noticed the brightness spikes again. This time, the slopes weren't just stair-step, they curved, folded back on themselves almost like waves crashing on an invisible shore. Some researchers whispered about complex rotational dynamics. Others suggested electromagnetic interactions. I just stared, mouth dry, heart racing. I ran a new simulation, comparing radar echoes from 3 different observatories. All aligned. All consistent. The timing was too precise to be a fluke. Maybe it's an artifact, I muttered to myself, but deep down, I knew the anomalies weren't in the instruments. Around 2 a.m., a faint chime sounded from my secure chat. An anonymous message. Patterns are converging. Stay clear of raw feeds tonight. No name. No signature. Just a warning. I froze. Part of me wanted to ignore it. Part of me wanted to see everything, capture every detail. I couldn't. Something in my gut told me that tonight would be different. Outside, the air was unusually still. Normally the ridge carried the dry wind like a song. But now it was silent. Even the distant hum of the nearby settlement felt muted. And above, a faint greenish glow hovered near the expected path of the comet. My eyes weren't deceiving me, I could feel its presence. Back inside, the console alerted me to another anomaly. The tail had shifted, a subtle bend inconsistent with solar wind. Radar returns pulsed in a slow, deliberate rhythm. Some of my colleagues online were noting similar events, but only half-formed comments, always cautious, always vague. Did anyone else notice the tail structure? Seems odd. Maybe natural, maybe not. I couldn't resist zooming in. Each pulse now carried microstructures, tiny brightness ripples nested within larger peaks. Not noise. Not thermal. Not dust. Something deliberate, layered, almost intelligent. Some researchers suggested it could be self-modulating gas emissions. Others dared to whisper about shielding effects or interstellar debris arranged in a pattern. Around 3:30 a.m., I grabbed the radio. My friend at the array replied almost immediately, voice tight. 3 readings just aligned. Directional. Coordinated. I've never seen anything like it. Aligned with the comet. I asked. Yes. All pointing in the same vector. And the signals, well, they don't repeat, but they pulse. Pulse. Coordinate. Align. Words we never use for comets. Yet here they were, whispered between lines of data. I leaned back, staring at the dome. The floor beneath me felt warm, almost imperceptibly. The instruments hummed, but there was a deeper vibration, subtle, rhythmic. Machines hum, machines rattle, machines whir, they do not pulse. I stepped closer. Hand on the telescope. Felt it. A soft, slow vibration, like a heartbeat. And then the monitors blinked. Another brightness spike. This one, enormous compared to the earlier patterns. Curved at the peak, cascading downward in microfluctuations. Something inside it was interacting, adjusting. Responding. Not randomly. Not passively. Responding. I tried to rationalize. Atmospheric distortion. Instrument drift. Heat exchange. But nothing fit. The same pattern repeated across multiple devices, multiple observatories. Some researchers online hinted at theories, interference, resonance, self-oscillating ices. But the pattern was deliberate. By 4 a.m., something else happened. Access logs changed again. Files I had previously secured were flagged, some blocked entirely. I double-checked backups, pristine, untouched. But the official systems had hidden the data, locked it behind permissions I didn't have. Somewhere in the back of my mind, a quiet voice whispered, "They don't want you to see this." I ignored it, mostly. But instinct won over. I started saving everything in offline drives, encrypted, scattered in innocuous folders. Every anomaly, every pulse, every microfluctuation. Then the tail. The tail curved upward slightly, almost imperceptibly, before the main pulse. Microjets in the coma seemed synchronized with the brightness spikes. Some researchers suggested a rare cometary resonance, others murmured about electromagnetic self-modulation. No one had a solid explanation. No one would dare publish theories yet. Around 5 a.m., the first light of dawn crept over the ridge. I stepped outside, shivering. The sky was a gradient of deep purple to soft orange. 3-IR Atlas was a faint pinprick. I could almost feel it drifting, silently, cold, ancient. My own breathing felt loud, out of place. I tried to convince myself that nothing extraordinary had happened. And yet, I knew it had. Because in the quiet, I felt observed. Not by people. Not by satellites. Not by instruments. But by something else. Something beyond my understanding. Something interstellar, deliberate, almost aware. I don't know what 3-IR Atlas carries. I don't know why it pulses. I don't know why the radar returns align, why the tail bends, why microfluctuations follow a pattern. Some think it's natural physics stretched to the extreme. Others, in forums and private chats, whisper about shielding, about intelligent phenomena, about interstellar visitors. I don't know. What I do know is that it isn't done. Not yet. And we aren't finished observing it. I looked up one last time before leaving the ridge. The horizon glowed, the first birds were stirring, and 3-IR Atlas drifted through the void, silent, cold, purposeful. And I had a feeling, call it instinct, that the next anomaly, the next pulse, the next layer of secrets, would arrive sooner than anyone expected. Whether it's coincidence, natural anomaly, or something else entirely, I cannot say. But one thing is clear, I am not the one observing anymore. I am being observed. And whether this means anything at all, well, that is up to you to decide.